Okay, last video for 601. Let's recap real quick. The second video, area between curves number 2, we did this problem. We finished with it, where we had to write the integral used to represent the area bounded by these graphs, x equals 1, y equals 2, and this function here in the first quadrant. So it was this area here, which represented one rectangle. We integrated with respect to x in this case, which represented a rectangle, and then this section here. So in order to integrate with respect to x, we actually had to split the integral into two pieces because the top curve and the bottom curve were different for the entire section from 0 to 8. And we found the 0 to 8 by getting the point of intersection here. So from 0 to 4, the top curve was y equals 2, but the bottom curve was y equals 0. So that represents this first integral. And I'm sorry, I've been saying 0, but I actually mean to say 1. And from 4 to 8, the top curve was y equals 2 again. Bottom curve was actually y equals the square root of x minus 4. So we had to take this and split it up into two pieces. So what happens though if we integrate with respect to y? Same problem, same example, same graph, but just respect to y now means we're dealing with horizontal distance instead of vertical distance. This is when we have to do the right curve minus the left curve. So the right curve, and if you notice, if you just check out in the first quadrant, we're going to be taking care of this section. And the right curve is always this square root of x minus 4 piece. From here to here, always, it's on the right side of x equals 1. So that's good. We don't have to break it up into two integrals this time because if you look at the right curve minus the left curve, it doesn't change. Whereas in the last one, it did change, top curve minus bottom curve. The bottom curve was different from 1 to 4 than it was for 4 to 8. Okay, so the right curve represents this y equals square root of x minus 4, but remember, if you have it and solve for y, it means we're talking y coordinates. So we would be talking like this section here, if I draw vertical lines going down. Well, that's not what I want horizontal. So I'm going to need to solve this for x. And this one's already solved for x, the right curve minus the left curve. So I'm going to take this orange line, the distance on this orange line, solve for x because it'll give me an x value, and then subtract 1 from it because this section represents x equals 1, and then that'll leave me with this orange piece right here, which is the distance between them. So if you have y equals the square root of x minus 4, if you want to get x by itself, we need to square both sides and then add 4. So that's where this comes from. This is the right curve. And then x equals 1 is the left curve. And then because we're going on the y-axis this time, we're going from 0 to 2, this section here. And we can simplify this and get y squared plus 3, and that represents the area between the right curve minus the left curve. And we don't have to find the area, we can just write the integral like the directions say. Okay, like I said, this takes a lot of practice. Just remember when you're solving, or I'm sorry, when you're integrating with respect to y, you're dealing with horizontal lines because you're measuring to the y-axis, which deals with x equals. And if you're integrating with respect to x, we're drawing lines to the x-axis, which gives us vertical distance, which is actually what a y value is. Okay, let's do another example, last one. Find the number a such that the line y equals a divides the region bounded by the curves y equals x plus 1 and y equals 5 into two regions with equal area. Okay, so our final answer is going to be a horizontal line, y equals a is a horizontal line because a is a number here. Let's draw a picture. So if we're bounded by y equals, these directions need to say in the first quadrant actually, or bounded by x plus 1, y equals 5, and x equals 0. So let's pretend that's in there in the first quadrant. Okay, so we need to figure out the a value that would cut this in half, cut this area, this yellow piece, into two regions with equal area, meaning it's some horizontal line somewhere, I would guess somewhere around here, where these two things are of equal area. So now what? This is where we have to actually set up two integrals and set them equal to each other. And we're going to have to solve, or I'm sorry, integrate with respect to y here because we're going to measure along the y-axis, which means we're going to be dealing with with x coordinates here. So we're measuring horizontally, which tells us that we're going to integrate with respect to y, and we're going to need to solve for x because this horizontal distance is measured by the x-axis. Okay, and we want this area to equal this area. We want this little triangle here to equal this trapezoid here. And our limits of integration are going to be from 1 to a. That's going to be the integral of the triangle. And then we're going to set that equal to the integral from a to 5. And then go from there. Okay, so let's set up this integral. If we want to get the area in this triangle right here, all of these represent x coordinates, and they're all x coordinates of this line right here. This line is y equals x plus 1, but if we want them to be in x coordinate form, it's going to look like y minus 1. So let's clean this page up a little bit. And the next piece is actually the identical shape. I mean, sorry, I don't want to say shape because I'm saying triangle and trapezoid here, so you can see the difference between the two pieces that we're trying to make equal. But they're both the same integral because we're trying to get the area between the y-axis and this line right here. And because this line is this way, again, if you have it written in y equals form, y equals would give you a distance this way. It would tell you how tall it is. And we don't need how tall it is. We need to know how wide it is in this case. So that would represent an x coordinate because we measure horizontally this way. Okay, so we have two integrals. One of them represents from 1 to a. That represents this piece. And it's just the integral of y minus 1, x equals y minus 1. And then from a to 5, the integral of y minus 1 again. It's the same line. So for this one, you actually have to integrate it. We're going to need to solve for a, so we have to use a fundamental theorem. So let's integrate. This will be y squared over 2, and then 1y from 1 to a. And again, the same thing, y squared over 2, and 1y from a to 5. Use the fundamental theorem, plug in a, and plug in 1. So this will look like 1/2 a squared, and then minus a, and then over here do the same thing. So we're using the fundamental theorem. We're plugging it all in. Kind of messy, but it's just algebra at this point. So this is 1/2 minus 1 inside here. This is 25 halves over 2 minus 5. And if you simplify a little bit, this side is the 1/2 a squared minus a, That's this piece here. And then minus, this is 1/2 minus 1, and we're subtracting that. So inside the parentheses here is negative 1/2. It becomes positive with that minus sign. And then on the right side, we have 25 over 2 minus 5. I made that 5 a common denominator already. And then minus 1/2 a squared again. And then plus a, we have to distribute that negative sign to both. Okay, so now this is going to be 15 over 2. Oh, sorry, I just running out of room. So this is the exact same thing I had a second ago. And this is 15 over 2 right here. And then I brought this 1/2 over by subtracting, and it created a 14 over 2. I also moved some stuff over here. This negative 1/2 a squared came to this side, added it. 1/2 and 1/2 makes 1. And then this positive a also came over here, negative, so now there's negative 2 a's on the left. Simplify this. Equals 7 over here, set it equal to 0. And now this is not factorable, so let's use the quadratic formula. And then simplify. I know I'm going fast. I expect you to pause and do it yourself. Make sure that you are getting the same thing I am and understanding. And then final answer. Oh, you don't really have to simplify the radical. I guess I'm just an overachiever sometimes. Final answer is 1 plus or minus 2 square root of 2. We don't really need the negative one. We're only concerned with what this a value is here. So it's just 3.8-ish. So the main idea for this one, though, was to just set up two integrals integrating this line with respect to y and going from 1 to a for the first one and a to 5 for the second one, and then setting them equal to each other. So you can use the fundamental theorem and then solve for a that way. All right, 6.01 done. On to 6.02 now.